Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. This is Speaking of Reliability, and this is Carl Carlson.
And this is Chris Jackson, and Carl and I are going to talk about the role artificial intelligence, or AI, can play in reliability engineering.
And focusing this podcast on some of the limitations to be concerned about.
Right. And I think AI is seen as the panacea for so many ails in society. And it's a wonderful tool, but it's just a tool. A hammer's a wonderful tool. You still can't build an entire house with just a hammer, though.
Yeah, it's the context. And of course, it's changing so fast and getting more powerful, that type of thing. And I'm deeply concerned that in some cases, it's being oversold in terms of what it can do, and thereby replacing human thought and concern and teams and that type of thing. So I just thought it'd be a fun podcast to share what we've learned about this as of this date, because it's going to change by next week and next month.
Right. Yeah. Well, I think I use AI in reliability engineering, but I have seen, let's go straight to the extreme edge. I've seen people advertise the ability to have a FMEA, for example, done completely using AI. And that's awful. That is absolutely terrible. Let's be honest about what AI does. AI is the voice of the mediocre. And let's not try and quibble about that. I mean, all AI does is review and research and go through all the words that have been written about a particular topic that it has access to. And the main focus on AI these days is more about sort of more natural talking, big market for it in being able to write essays for university students. But in the world of reliability engineering, you just don't have this plethora of journals of how good reliability engineering is done. So many organizations out there do a fantastic job at reliability engineering, but don't write a journal about it that an AI machine can hook its teeth into to try and spit out a wonderful product. And more importantly, beyond all that, is if you have someone that you pay to generate a FMEA, which is completely based on artificial intelligence, it just gives everyone in that organization an excuse to stop thinking about reliability. And there's not been a single product designed where the design team, sorry, a reliable product, I should say, where the design team has not had a really robust quality and reliability mindset. If you outsource thinking, bad things happen every single time.
Yeah, and as you point out, it's almost like revert to the mean. The broad set of information about reliability is a mixture of some really good stuff and some really bad stuff. And so when you integrate that together, you get, as you point out, mediocrity. It certainly is possible to train an AI search engine internally in a company on certain set of information and documents. And then that would open it up to some type of screening as to what the AI is trained in. And that's a possibility. I don't know that that's how deeply that's been considered. I likewise have concerns about, and I've heard this multiple sources of people going, wow, and we can have AI do the FMEA. And I can probably tick off about 10 reasons of deep concern about that, not the least of which is the decisions of what you enter into the worksheet or the database has to have some type of screening, and it's usually a cross-functional team. AI can be really useful in making sure you don't miss something as thought starters. So I don't want to come across negative. There's tremendous usages in terms of understanding failure rates, that type of thing. But when you have new designs, new technology, new environments, new operating conditions, those all stretch the imagination of subject matter experts to anticipate what could go wrong. And that's not sitting in the rearview mirror in databases. And so I do have a
Yeah,
deep concern about it. Go ahead.
I would agree. I mean, I've been working with a client who in the medical device industry, and they're trying to do something amazing and new with their device. Now, if you were to get an AI-based company to go and do a FMEA for that device, then essentially all you're asking, or what you're doing is asking the world's best librarian to research as many articles, journals, blog posts, what have you, that have been written about that medical device and sort of quickly summarize historical issues as mentioned in those journals. Now, let's just call this librarian Hilda. Let's give her a name. If you were in a medical device company and you seriously said to the boss, "Hey, there's this wonderful librarian just down the road. Her name is Hilda. She can research anything. We're not going to do it for Mia. We're going to get her to do it with her research skills and put it into a table, and we're done." Now, if you're comfortable saying that to your boss as your proposal, then okay, now you should be comfortable saying to your boss, "Well, we're going to get an AI, get a FMEA done exclusively on AI because that's all you're doing." Now, the problem with that, as you pointed out, is that you need to stretch the imagination of the subject matter experts, um, because you're trying to do something new and amazing. If you're not trying to do something new and amazing, you're not any of the companies I associate with in terms of what they're trying say they're trying to do. But it just doesn't work. If you can trust Hilda, then sure, trust AI. But no one in their right mind would trust a librarian, even the world's best librarian, to tell engineers what the corrective actions need to be for their design for this system without even actually looking at the design for that system. It's just beyond crazy.
So let's build on that example. The I agree, you wouldn't ask AI to decide on the corrective actions, but what you could do is say, ask AI, what has been done in the past?
Right.
And then consider that, because sometimes problems that we used to call them hardy perennials, to use the gardening analogy, things that just crop up year after year after year. And there are a lot of problems that are hardy perennials, and they have
Yes.
good solutions. And so we don't want to limit the subject matter expert team to their memory. AI can search out and say, okay, what have been the hardy perennials? What has been done in the past? That's useful input. But as you point out, and I was talking about earlier, very often the FMEA and reliability program is focused on something new that doesn't have that database of past failures.
Right. And so I'd be more than comfortable, if I was facilitating it for Mia, I'd be more than comfortable asking this hypothetical Hilda to go and do all the research she can on whatever it is we're looking at. But I would, as a facilitator, keep that in my back pocket and make sure that we do the proper full brainstorming process to try and push our subject matter expertise to its fullest extent to try and work out the issues associated with our design, not historical designs. And then and only then would I pull out of my back pocket the stuff that Hilda has researched and says, "Hey," and I go, "Hey, team, have we got these as well?" And the answer will be yes or no. Glad we pulled those out. We were missing those.
Here's an idea. What if we have Hilda or an AI bot become a member of the FMEA team, not the leader, but a member? And that way, the team can look to the AI bot or Hilda and say, what do we know about this from your experience, da da da. And then she can offer that input and it's considered as input. What do you think about that?
Yeah, so I mean, the only thing I want to preserve is that brainstorming effort, and I think you'd agree with that. You want my little trick is when I'm facilitating, I just ask people to write down on a piece of paper, the top three things, whatever question we're asking. Give me at least
Yeah.
three things, at least three reasons why this might fail, or what three, what are your top three functions? And usually people write more than three, but just give them a baseline target of three. Um, so I find that human beings can't see what's missing easily. like really good at building stuff or describing stuff from scratch. But if you put a finished, for me, a worksheet in front of them or a finished analysis or whatever, it's very hard for us as human beings to see what's missing. And AI can produce something which looks like a relatively robust artifact or product, which is borderline impossible to examine to see if anything's missing. And so my only concern with that AI bot is we don't want that AI bot to take over the brainstorming process or feel like people can stop thinking because if, the AI bot will pick everything up. That'd be my only concern.
That's a good concern. I like the way you word that, Chris. And I feel the same way. I've taught this for years. The problem with pre-populating, and I have an article on Ascendo about pre-populating FMEAs. There's certain columns you can have a draft, but the problem with doing that is people don't see what isn't there. And that's that. So we're saying the same thing. And
Mhm.
that's really profound because if you, I have tried this and I've seen people try it where they say, okay, here's a candidate. Joe put it together in his over the weekend, and here's a candidate spreadsheet with a bunch of information in it. Please review it and make sure it's not missing something. It won't happen. People don't see what isn't on paper or in the database very easily.
And that's a human thing. It's not a competence thing. It's a human thing.
Right, right. And so that is so important that we don't shortcut the brainstorming process. So this is a really tricky subject, and I really encourage people to think about this deeply. So going back to what's the purpose of FMEA or what's the purpose of a reliability program? So let me just make a comment on both of those things. On an FMEA, the purpose is absolutely not filling out a form. If your company wants to do FMEA to fill out a form, hire an AI bot and it will fill out the form very nicely. And some customers will check it off. Like in the automotive industry, yeah, years back and even to some degree today, suppliers are required to do an FMEA, and it's essentially a checkbox. Did you do it? When is it done? That kind of thing. But that's not good enough in driving good designs. So I think we have to go back. What's the purpose of an FMEA or what's the purpose of a reliability program? And it really is a thinking tool. So you want to improve the design in a design FMEA or improve the manufacturing process. And you can't do that by filling out a form. That doesn't do anything. You also want to reduce risk to an acceptable level. And I see no way that filling out a form is going to do that. And then a reliability program, same kind of thing. So you're trying to identify gaps and you're trying to close those gaps and achieve high reliability. And in the middle of that, and Fred in my book, that's probably bad grammar, but our book, um, we have a step in there called support reliability decisions. And that's where management has certain decisions to make. And we want the reliability program to support those decisions. I can see that being done very with great mediocrity in using AI to here's a list of things to support that decision, but it won't get where you need to go. And that's so there's a human element on this that is critical. And someday, maybe in the future, AI will surpass that. I haven't seen that, and I don't know when that would happen. It's certainly not there now.
No, and it's very reminiscent of some of the issues I had with some of the military projects I worked on. I remember I was working with a company which is building a new vehicle, wheeled armored vehicle, and for a military customer. And this company didn't have much experience doing FMEAs. And so they outsourced the FMEA, or FMECA in this case, to an aerospace company, which had lots of experience of doing FMEAs and FMECAs for the military customer. And so they got this wonderful worksheet, which is thousands of pages long, um, but the vehicle kept breaking down. And
Yeah,
so
that's yeah,
it's just people, that is almost analogous to asking an AI bot to fill out a worksheet. Just get something, some entity which has no experience with this thing we're making or designing for the very first time, get them to fill it in just so we can have that form looking spick and span and tick that box and move on. But of course, things don't work like that. It's just not a thing. And there was much gnashing of teeth. And I was in there, I was being asked to, to assist the organization. And the military customer simply could not get it. In that the for me his main role is or for me, even for Mika, for me and for Mika's main role is to help you find corrective actions for design. It's not there to compile failure rates. Not a single standard out there advocates that as being the sole output of a FMEA or a FMICA. It's not to do it's not just to tick off a milestone. It is there to help you make better designed decisions. And if it's a process for me, better manufacturing decisions. And if it's a software for me, better software decisions and everything else. And they just could not get it. But and they wanted to blame the contractor for not doing the right thing and say, well, why do they get this outsource of FMEAs and everything else? Well, that's because you approved the FMEA that they got. So they outsourced the FMEA, submitted it to the defense customer, and the defense customer looked at all the standards that they wanted it to comply with, said, yes, this complies with the standards, and approved it. And say, well, you signed off on it. So what is your problem? It is this circuitous blame game which just never goes away. And I can all but guarantee that if you ask an AI bot to do your FMEA or FMICA, it will be next to useless in terms of coming up with, you know, useful corrective actions to help influence your design in a positive way.
very nicely said. The uh, a story comes to mind. I'll do a RAM story. The For year after year, and I'll just state that I'm essentially retired from Rams for the listeners, but I spent about 30 years doing tutorials and things. So I was there a lot.
I might be retired too now.
Yeah. And year after year, uh, someone would be presenting a paper or be on a panel talking about automated FMEAs. I'm sorry, this goes back 20 years. And I just put them in a certain folder in my computer, knowing that it's someday I want to pick this up and do something about it. And then about 3 years ago, I got to the point where I want to do something about it. And so I organized a debate at Rams, and I'll call it an Oxford style debate. An Oxford
Hmm.
style debate, everybody gives their opening statements, and then the panelists can ask each other questions, and the audience can ask questions, that type of thing. And so you really got to be on your toes. It's a very good format uh, to do a debate. And we did it. Two panelists were in favor of automated FMEAs, and two panelists, myself, one of them, are team-based FMEAs. And by the time we were done, we found a lot of common ground. The automated FMEA people said, yes, humans need to be involved.
Okay.
And the team-based people said, there's a role for automation in terms of making sure you don't miss something or collecting up information. And we basically came together in a nice way. Um, and I think we put at that point in time a deep concern about automating FMEAs, and that was about 3 years ago. That's a limited audience, of course, because Rams has its audience, and the advent of AI is very attractive, and so we got to be on guard. The other very short I'll mention is before this podcast, I went to check AI on what AI thought about MTBF, whether that's a good reliability metric. And it pretty quickly got to the point where, yes, it's a good metric if you're in the flat part of the bottom part of the bathtub curve.
That's evil.
Yeah, and I have enough experience in this, and I know you do, Chris, and you're very articulate on it. Is that that's a there's huge caveats on that, and the pervasive assuming exponential distribution has been a misuse of reliability methodology for years, an overextension. It's not like it can't happen, but it's been assumed where it shouldn't be. And
Right.
so if AI, if that's the answer I get and I run with that, that's a problem.
Right. And just to clarify, I mean, there is a lot of people know what the bathtub curve is, but there are precious few real life scenarios where the bathtub curves emerges as beautifully as that's seen in textbooks. There's a reason, because there's not a single bathtub curve in textbooks, which is anything more than a stylistic representation of different phases of wear in, useful life, and wear out. And you see time and time again that seemingly qualified reliability engineers tend to assume that there's this bottom of the bathtub curve just sitting there waiting for us to enjoy, because these textbooks have these beautiful bathtub-like shapes. And in reality, most bathtub curves look more like a check mark or a tick mark. They might have a region of decreasing failure rate, but it rarely sits at a constant for very long before the dominant wear out failure mechanisms start to increase. And as you keep going, they increase even further and further and further. And yeah, bathtub curves exist in some cases, but they're not a bath. Bathtub you could easily take a bath in terms of the actual shape. And but I see this assumption made time and time again, and that you are able to just wait out until you hit the bottom of that bathtub curve, which is not a thing 9 times out of 10. And because we see that in textbooks, people just say, all right, well, and everything has a bottom of bathtub curve. And do not get me started on that whole Nolan and Heath paper, which
Yeah,
gets cited time and time and time again. And that's a great example where you will have people say, well, 89% of failures have essentially have a constant hazard rate because Nolan and Heath did a study on McDonnell Douglas aircraft back in the late 70s. That's
right.
nonsense. To suggest that 90% of your things will never wear out, like never, like not, that's crazy. Um, and so it's not even like Nolan Heat did their study on an aircraft engine, which is now retired, but back in the late 1970s, where these days aircraft safety is an order of magnitude better than it was back then. So even today's aircraft engines are fundamentally different to the engines they studied. And to say that the aircraft engine they studied is in any way, shape, or form similar to your milling machine or or a solenoid, whatever it is
Yeah.
you are going to assume has 89% of its failures with a constant hazard rate, it's just laughable in the same way.
It's intellectually lazy.
Right. But even then, I actually looked at the Nolan and Heap study. They stuffed it. I've written an article on how they mismanaged.
Hmm.
They have made some assumptions that a first year statistics student at a university would go, hang on, that's not right.
I'll add 30-second story onto that, and then I
Go
want
for it.
to pose another topic on this, and I know we got to wrap up pretty soon.
Yeah.
The Back in the early 90s, GM had a lot of interns, and I was manager of product reliability. And so I get an intern, always have to come up with a project. So I thought, well, this would be interesting to go to the um, GM ran products from every manufacturer,
Hmm.
automobiles, every manufacturer around the world on the 100,000-mile or equivalent test track. And
Right.
they said they had tons of real data about failures. It was an amazing database. And so I said, why don't you go check that database and tell me whether or not there's a reliability bathtub curve? And so it took quite a bit of time to do it because you have to aggregate lots of information. But when it was done aggregating, just like you pointed out, it was a check mark. And there was no flat part to that curve. And this is a very real, in my opinion, a very real database. because automobile is complex. There's a lot of repairs that go on, that type of thing. And getting failure data that showed that check mark. I wish I had that data. I'd write a paper related to it, but that went somewhere else. One other comment I'll make, and then we should wrap up. If you're going to use AI, which you should, there are ways to use AI in reliability and FMEA. Be sure it's input to a really good team. Be wary of what Chris said about you don't see what's missing, and make sure you're not putting in front of people information that they don't see what's missing. And then lastly is I would carefully look at the citations in the AI and see if they're valid, because a lot of AI uses citations, and those citations are built on faulty data. So you can quite easily assess the validity of the data you're getting. So those are some thoughts I have. Any wrap-up comments, Chris?
No, well, yes, couple. Just get the AI to fill in the gaps, not the other way around. Do your hard. People looking for AI, let's be honest, to try and get out of having to do work. That's what the main reason people look at AI for. But do the hard work and let AI fill in the gaps. That's my first point. And like do that for use cases as well. It's really good to brainstorm a use case for something to get AI to fill in the gaps and even draw the person to help you build empathy. And the second thing is, well, that example Carter's talked about where you can use the MTBF as long as you're at the bottom of the bathtub curve, that is just parroting the wrong information. It's just a great example of the limitation of AI. If you have AI tuning into a lot of nonsense, then AI will then very proudly and very authoritatively output nonsense as well. So you can't stop thinking. If there's a key message, AI can certainly help you, but you can't replace thinking. It's just all AI does is a summary of the mediocre. And if you want your product to be more than mediocre, different, which a lot of information won't be out there to help you make it reliable, you need to use those smart people you pay lots of money to design reliable stuff to help you out with.
Good summary. If you're a listener and have some thoughts about this, have some experience about the use of AI in reliability or FMEA, please get in touch with us. I know our contact information's on LinkedIn. It's certainly on Ascendo Reliability. Any other places they can go to if they want to leave a message for us?
Yeah, so please check out Shendo Reliability /series/SOR for our Speaking of Reliability podcast. And of course, that will give you information about where to reach out to us if you need to. But yeah, I think we're done talking about AI, and we could talk about AI for a good 3 hours.
We're done for today.
Yeah, so we'll just leave that there for right now, and we'll see how we go.
All right, thanks, Chris.
Thanks, Carl. Always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.